I'll take a shot of the client side.
Like the hard part is knowing which one is
Oh, I think two of us are trying to go to the same.
So I turned into Felipe. So all of those S's are me dead, and I'm gonna reach up.
Whoa,
Yeah,
are you the
someone's
long?
Wait.
Circle, you should circle.
Here's how socket connections work in our project. At first we start with a very basic, very usual listen socket build up. We create our socket, we define our address, define our port, and then we bind our socket and start listening. This all happens in the main function just before our game loop starts. Then, before our game loop starts, we also define a struct timeout. We set it to 0. This way we can do polling on our players, both for those who would like to join the game and those who are already in the game. One thing to consider is in our game loop, we have two FD sets. We use the first FD set join request for only listening to the listen socket, and we use the secondary FD set for those players who are actively in the game. So when a player wants to join the game loop first checks if we reach the maximum amount of players. If we did, it doesn't even call select, it just ignores it. If we didn't and there is space for new players, then we call select on the listen socket, see if there is anyone who would like to join. If there is someone who would like to join, we add that person with a private socket to our players list. We have a list of player structs who hold the crucial information for our socket implementation. And then we use our second FD set. We add active players into the set, and then we call select on the set. The result of the select, we iterate over it, and then we observe the players who registered a valid move, and we change the player struct accordingly and use those moves to implement the rest of the game logic.